we look at determination of elements. How can we determine elements present in an organic compound? Remember, in an organic compound, the elements that we are likely to see in the organic compounds are sulfur, nitrogen, oxygen, aside carbon, okay? Sulfur, nitrogen, oxygen, and the rest of them. So now, how can we determine these elements in this organic compound? There is a popular test called the sodium fusion test. Okay? So that's also called the Lassane test. So what do we actually use this test for? We use this test to determine elements such as nitrogen, sulfur, and halogens. Remember, what we say halogens? Halogens include chlorine, fluorine, iodine, and what? Bromine. Okay? These are the elements that are what? Called halogens. Okay? So we use this sodium fusion test to determine these elements. Okay? Which includes nitrogen, sulfur, and halogens in organic what? Compounds. Okay? So organic compound. So how do we carry out this analysis or this test? The organic compound is fused with sodium. Okay? Sodium, the normal element you know as sodium, to convert the covalently bounded element into ionic forms. So what it means is that if you react these elements with sodium, okay, such as this, so they will covalently what? Bond with what? With that organic compound, thereby indicating releasing what? Those elements that we mentioned initially here. So this is an important test that we use to differentiate or to determine elements such as nitrogen, sulfur, oxygen, and other halogens. Okay. So now, the next thing now is how can we determine the empirical formula of an organic compound? Of course, the empirical formula is the simplest ratio that the organic compounds can have. For example, the empirical formula for benzene. Benzene is C6H6. So this C6H6 is not actually the simplest ratio because 6:6 can be expressed. This is not the simplest ratio, okay? So the simplest ratio here is what? 1:1, because if I divide this by 6, I have this. So the empirical formula for benzene is actually what? CH instead of C6H6. So here the ratio is what? 1:1. So empirical formula is the simplest whole number ratio of the atomic what? Of atoms of each element in a compound. Okay? So it is determined from percentage what? Composition of elements. Okay? So now, how do we determine the empirical formula of an organic compound? Now quickly, I'm going to clean here, for example, to show you. Okay? Since we are dealing with organic compounds, how can we determine the empirical formula? We can determine the empirical formula from their percentage composition. Okay? So how do we do that? Remember that if I have an organic compound, and the organic compounds react with oxygen in excess, I will definitely have CO2 plus water. So we can determine the percentage composition of the elements in this organic compound. Okay? If we know the mass of the CO2 and the mass of the water that is produced from this combustion reaction. So mathematically, the percentage of carbon in this, remember in this product now I have carbon, oxygen, hydrogen. So there could possibly be carbon, hydrogen, and oxygen from this combustion data. So how do we find it mathematically? The percentage of carbon is 12/44 times the mass of CO2 produced all over the mass of organic compound. Okay, times 100/1. So with this I can get the percentage of carbon. So how do I get the percentage of hydrogen? The percentage of hydrogen becomes 2/18 times the mass of water from the combustion data all over the mass of the organic sample, of the organic compound. Okay, times 100/1. So the last one being oxygen. So how do we get percentage of oxygen? It would become 100 minus the percentage of carbon, that of hydrogen, sum it together, subtract it from this guy, you get for oxygen. So from the combustion data, once we have gotten the percentage of carbon, hydrogen, and oxygen, then we can go ahead and solve the empirical formula the way you know. So empirical formula, how do you solve it from your secondary school? You should be able to use the percentage composition of these guys to get your empirical formula. Okay? So the last one we'll talk about is the molecular formula. Okay, the molecular formula is now the actual number of atoms in each molecule of that compound we are talking about. Okay, so we can obtain it by making use of the empirical formula we have gotten from this. Okay, so and also from the word molar mass. Sometimes they will provide you with the vapor density. Okay, so with vapor density, which is Vd, you can also vapor density times 2 is equal to molar mass. Take note of this. So sometimes you might be provided with the vapor density, multiply by 2, it becomes the molar mass. Okay? So also from here now, the molecular formula is N times empirical formula. This is the empirical formula you have gotten from this place, okay? From here. So when you know the empirical formula, this N is the repeating unit, okay? So how do you get this N now? This N is calculated by dividing the molar mass with the empirical formula mass. What is empirical formula mass? Let me show you quickly. Okay? Let me show you somewhere here. Let's say a compound has an empirical formula to be CH2. The empirical formula mass will be equal to atomic mass of carbon is 12, hydrogen is 1 times 2 is 2, so the empirical formula mass is 14 grams. So take notes. So I believe that you can do this. If I have CH2O, what is the empirical formula mass? The empirical formula mass becomes 12 plus 2 plus 16. So I think you have 30. So this is how to get the empirical formula mass. Okay, so you now put this value here. The molar mass will be given to you in the calculation. But if it's not given to you, sometimes they will give you vapor density, multiply by 2, you have the molar mass, you still put it at the top here. Okay? So there are more problems you can see on this that will help you understand how to find this. Okay? So this is how we can get the molecular formula and how we can determine the what? The percentage composition, which will help us get the empirical formula of that compound.